Why, hello, fancy meeting you here. Okay, so we are going to go into the next section of solving quadratic equations. And this one centers around solving when it looks like vertex form, or sometimes we'll have to do a little complete the square to make it look like vertex form, okay? But in here as well, I'm going to do a bunch of examples with you. In here as well, there's also a conversation around doing what's efficient, okay? There are going to be questions that you see right away are factorable. Well, if they're factorable, go ahead and factor it. That's probably the most efficient way. There are going to be questions that you look at and you're like, whoa, I can't factor that. That's when you start using other methods, okay? But usually solving by factoring, which we did yesterday, that's always kind of your first go-to. If you can factor, that's usually the easiest way to get it done, algebraically showing your work, okay? All right, so yesterday we learned that one way to solve a quadratic equation is by factoring, but in some cases this won't be easy or efficient or even possible. So today we learn another method to solve quadratics. Before we do, something super important, which if you follow my videos or if you pay attention in class, you will have noticed I have said this several times. No matter what grade level you're at, you must have heard me say this before. But if I was to solve x squared equals 9, when I go to take the square root of that, there are two possibilities, okay? And that is so important to everything we're going to do today. If you don't catch that there are two possibilities, you're going to lose half of your answers, okay? And that kind of sucks. So x squared equals 9. We're looking for a value for x that would, when I square it, equal 9. There are two possible values. That would be positive 3 or negative 3, okay? So big take-home message before we dive into anything. When you are taking a square root, it could be positive or negative. So you're always looking to have that plus or minus sign, okay? All right, so when we take a square root while solving an equation, we have two answers. We could have a positive version or a negative version, and this is known as the square root principle, okay? All right, so always think about what method is the most efficient. Doing it in a non-efficient way isn't wrong. I'm not going to mark you down because you didn't do it the easiest way, but the problem is you might run out of time on your test, okay? The test that we would give you would be designed that you are going to use the most efficient method possible, okay? All right, so here we go. We're going to take a look through these. Now, some of you may look at this and say, oh, okay, I have to go x minus 5 times x minus 5. I have to FOIL that. I have to bring everything over to one side, and then I have to try and factor it. You can, but I wouldn't call that most efficient. Remember, if I'm trying to solve this, I'm trying to get x all by itself. Well, the easiest way to get x all by itself, like think this through. If I multiply that out right now, I'm actually going to end up with an x squared term and an x term. That's actually making my life more complicated right now than what I'm already looking at. If I want x by itself, all I have to do is get rid of the square and get rid of the minus 5, okay? So if I square root both sides, I'm going to get x minus 5 equals plus or minus root 2. Then I just have to add 5 to both sides. X equals 5 plus or minus root 2. That's my answer. If I had multiplied all this out and brought the 2 over and tried to factor it, it wouldn't have been factorable. So then I would have been even more frustrated, okay? Look for the path of least resistance. Look for the easiest method to get to where you want to go, the most efficient method for where you want to go. You wanted x by itself. The easiest thing to do here is just square root both sides and then add your 5, okay? So there are two answers here. One answer is 5 plus root 2, and the other answer is 5 minus root 2. Okay, those are the solutions to this particular equation. Okay, so very similar. X plus 4l squared minus 21 equals 0. If I added 21 to both sides right now, I'm looking at the exact same scenario that I did in the previous slide. Okay, so now that I've added 21 to both sides, I can take the square root of both sides. So that'll be x plus 4 equals plus or minus root 21. And then just subtract 4 from both sides. So x is negative 4 plus or minus root 21. Now, I want to make sure you understand what's going down here. If I was to take my graphing calculator and graph this, okay, because it equals 0, I'd be looking for the x-intercepts, right? If I was to calculate those x-intercepts, I would get 2 solutions, but my graphing calculator would give me decimal approximations. This, negative 4 plus root 21 and negative 4 minus root 21, that is the exact value of those decimal approximations, okay? So if you don't believe me, grab your graphing calculator, graph this out, write down those decimals, and then take your calculator and go negative 4 plus root 21 and match the decimal, and then negative 4 minus root 21 and match the decimal, okay? I won't lie to you often. Okay, x squared minus 5x plus 6. Well, that to me is a quadratic looking thing. I want to first talk about factoring. Can I find two numbers that multiply together to give me 6 and add together to give me negative 5? Well, actually, I can. It'd be negative 2 and negative 3, right? Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So I don't want to go through completing the square here. That's not the most efficient method, okay? The most efficient method for this guy would be to factor it. So I'd go x minus 2, x minus 3. That's the zero product principle like we talked about yesterday. So I'd have x minus 2 equals 0 and x minus 3 equals 0. Therefore, x is 2 when I add 2 to both sides, or x is 3 when I add 3 to both sides, okay? Oh, sorry, I kind of left that really quick. I want to make sure you're okay with that. Okay. Now, this is, it kind of looks like it's in vertex form already. So when it's in vertex form like this, you don't want to expand it all out. I just need to add 27, divide by 2, take the square root, and add 4. Can you see all those steps in your head? Okay, I'm going to write them out for you in a second. But one of the great things, maybe you don't think it's great, but let me rephrase. One of the things I really try to push kids at school to do is to visualize where they're going. If you can visualize the steps of where you're going, then you're going to feel much more confident as you take those steps. Okay, so now let's write out what I just said. I know I need to get rid of the things that are farthest away from x first, so I'm going to add 27 to both sides, and I'm going to divide both sides by 2. I'm going to do that in one step, so that's going to give me x minus 4 all squared equals 27 over 2. I'm now ready to take the square root, and when I take the square root, we're going to have a few conversations around the radical that's there. So just stay with me because this will be the first time you've seen this. But when I take the square root, I've got x minus 4 on the left side, and I've got root 27 over root 2 on the right side, and it's plus or minus, okay? So some of you may have written like just a big check mark and said root 27 over 2. That's okay, but I'm actually going to try and simplify this out, and that's why I just put them on both instead, okay? Now, you will recall from grade 10 that root 27, well, 27 is 9 times 3, and the 9 can come out. I can simplify that radical, so that would be 3 root 3. And then I'm also going to add 4 to both sides. So then my next slide, let me just get ink here on. I'm going to bring that 4 over here, and I'm going to simplify that root 27 to 3 root 3. Now, if you lost what I had said there, that's 9 times 3, right? And then I'm going to bring my 9 out. The root of 9 is 3. That's where that 3 root 3 is coming from, okay? And so I'm looking at 4 plus or minus 3 root 3 over 2, which is pretty good. That's a pretty good way of saying it, but it's not the best way of saying it. I now want to what's called rationalize my denominator, okay? And what I'm doing here is we tend not to like a radical on the bottom. So what I'm going to do, I can get rid of a radical if I multiply it by itself, okay? So what I'm essentially going to do is I'm just going to multiply the bottom by root 2. Now, if I do that to the bottom, I have to do it to the top too, right? I can't change the equation. Okay, but then what that will give me here is 3 root 6 all over 2. Okay, and that's considered a simpler version. Okay, so 3 root 6 all over 2. And then the last thing I want to do, whenever possible in math, we would want to write as one fraction. So I'm not super keen right now on the 4 plus or minus the fraction, because I can call that 4 8 over 2, right? 8 divided by 2 is 4, okay? I can call that 4 8 over 2, and then I've got a common denominator, and I can just put it all as one fraction. So the best way of answering this question in an exact value would look like this: 8 plus or minus 3 root 6 all over 2, okay? Of everything I do with you today, that was probably the most confusing. So if you're like super stressed, take a breath. It's going to be okay. You're going to make it. You might want to rewind this one and just watch that process one more time. Okay. But it won't get harder than that. Okay. I promise. Okay. Now look at this. This looks like a friendly trinomial. So then I'm thinking to myself right away, hey, I want to factor this. Can I find two numbers that multiply together to give me -8 and add together to give me -4? And the answer is a resounding no, I can't. So I need to start manipulating this guy so that it looks like that vertex form again, okay? So I essentially am going to complete the square like I did a little while ago when I was doing standard form to vertex form. This one will be just a slightly different. And the only reason it's slightly different is because I get to work on both sides of the equation. And so instead of factoring something out, I could divide every term by that number, okay? So I just get to play by a slightly different set of rules. Okay, so I'm going to add 8 to both sides. And now I'm just focused on this guy right here, and I want that to be my perfect square trinomial. I want that to factor into a binomial squared, okay? Well, I have to figure out my magic number. My magic number is half of -4 squared. Half of -4 is -2. This should all start sounding familiar, right? We've done a process like this before. Half of -4 is -2, and -2 squared is 4. Now, instead of in the other context when we were writing a function, we would have to add 4 and subtract 4, right? Here, I'm just going to do it to both sides of the equal sign. As long as I do it to both sides of the equal sign, I haven't changed equality, okay? So I've got this cute little perfect square trinomial on the left, and then I've got 12 on the right, okay? So this guy's going to factor into x minus 2 all squared. Remember, the first term is the square root of the first term, the last term is the square root of the last term, and the sign in the middle is the sign in the middle. Now I'm right back to like that very first slide, that very first example I gave you. All I have to do now is take the square root of both sides. So I'm going to have x minus 2 equals plus or minus root 12. And then I just need to add 2. Okay, so final answer is 2 plus or minus 2 root 3. Now, before you yelled at me, we want to write things in simplified form. So I took root 12 and I thought, hey, 12 is root 4 times root 3, and the root of 4 is 2. So I just simplified root 12. Okay, again, that means there are two answers here: 2 plus 2 root 3 and 2 minus 2 root 3. Okay. Okay, awesome. I want to do that whole thing, that whole process one more time, because that's the first time I made you do that in this note. So I want to practice it again with you. So we're going to solve x squared plus 10x plus 4 equals 0. My first go-to is factoring. I don't know two numbers that multiply together to give me 4 and add together to give me 10. So factoring is not going to work. I'm going to go through completing the square again. Okay, so I'm going to subtract 4 from both sides. And now I will figure out my magic number. So I'm going to take that 10, I'm going to divide by 2 and square it. 10 divided by 2 is 5, 5 squared is 25. So I'm going to add 25 to both sides of the equation so that I maintain equality. Okay, so this guy, you guys are getting old hat at this now. This guy will factor into x plus 5 all squared, and then this will be 21. Okay, now I'm just ready to take the square root. Remember, when you take the square root, it could be plus or minus. There's always two possibilities. So this is going to be x plus 5 equals plus or minus root 21, and then just subtract the 5. So x equals negative 5 plus or minus root 21. Okay. You're rocking it. You're rocking it. Okay. 4x squared minus 9 equals 0. There's a couple different things you could do here. You could factor this. You could look at this as a difference of squares. So you could factor this into 2x plus 3, 2x minus 3, and then use the zero product principle and solve for each of those. I didn't do that here. What I did was I added 9 and divided by 4. So x squared is 9 over 4. And then I just took the square root of that because I saw that both of those numbers are friendly square rooted items. Okay, the square root of 9 is 3. I can do that nicely. And the square root of 4 is 2. So x equals plus or minus 3 over 2. If you had factored it, you'd get the same answer. Okay. Is one of those better than the other in this example? I think you can do both just as quick. So that I wouldn't be concerned about one method being more efficient than the other. All right. Here, though, again, you're not going to multiply all this out. You're just going to go through and get your x by itself. That's all we were looking for, right? So I'll add 15 to both sides. I'll divide both sides by 3. I'll take the square root and I'll add 1. Did you follow those 4 steps? Okay. I add 15 to both sides, divide both sides by 3, square root both sides, and add 1 to both sides. And that'll give me my answer. So here I go. Add 15 to both sides and divide by 3. That leaves me with x minus 1 squared equals 5. Now I'll take the square root. So that leaves me with x minus 1 equals plus or minus root 5. And I just add the 1. So x equals 1 plus or minus root 5. Okay. This is so fun. You got this. Okay. So we're almost done. So what we have seen is there is more than one way to solve a quadratic equation. Some ways are more efficient than other ways, depending on what the original question is, okay? What we need to do is to build our intuition. It's all about being able to look at something and knowing what's the easiest way to go about solving it, okay? That comes with practice. Do lots of practice. So important. It's the only way for your brain to make the connections that you need it to make, okay? All right, so this one goes the other way. Write a quadratic with roots of 2 plus or minus root 3. So I'm giving you the answer. You have to come up with a question. It's like Jeopardy, okay? So the answer is x equals 2 plus or minus root 3. Well, I'm going to subtract 2 from both sides. So I isolate for the radical. And now I just have to square both sides. If I square both sides, I'll have x minus 2 squared, and I'll have 3 on the other side, okay? You know how to square this very quick because you've been doing that for a lot of time. If you've been doing your homework, you've been doing that a lot of times in the last couple of weeks. Square the first, double the product, square the last. So you've got x squared minus 4x plus 4. And then I just bring my 3 over and there's my equation. X squared minus 4x plus 1 equals 0. Okay. Easy peasy lemon squeezy. Okay. Cute little algebraic lesson. You got this. You can do this. Okay. Please, please, please make sure you're practicing. So important. Practicing. So important. Okay. So here's your homework. And as always, if you have any questions, come chat with me or connect with me. Okay. You got this. I believe in you guys. Have fun.